In this video we're going to talk about deducing the structure of C8H10. So, if we look at the NMR, you will see that we have a triplet and a quartet, and if you watched video number one says that that's indicative with that 2 and that 3 of an ethyl group. So that is an ethyl group. The next learning part from this NMR is the fact that this is benzene. Anything between 6 and 8 is benzene. Hopefully you've got your data sheet on you right now so you can check that. So between 6 and 8, benzene. And there's 5 hydrogens giving that peak, which means it's missing one hydrogen, which means it must have a group where that hydrogen is. It must be substituted at that point. We call that mono-substitution. So here's the table. Here's the chemical shifts. Here's the peak splittings. Okay, and then you go down to the multiplet. Now this multiplet is for the benzene, because you don't have to analyse the peak splitting in benzene. You just call it a multiplet. So anything that comes between 6 and 8, just call it a multiplet, because that's benzene. And then we put our relative peak area 3, 2, and 5 on there. And then we start doing our type protons. Now we already know that the 2 peaks here are for our ethyl group. So we put our ethyl group on. And just to prove that to ourselves, let's do our n+1 as well. And there's your benzene. n+1 for the triplet, for example, is n plus 1 equals 3. 3 minus 1 equals n. That means n must be 2, which means there must be 2 hydrogens on the adjacent carbons. So that means this triplet right here is next to a carbon with 2 hydrogens on it. Well, there's the carbon with 2 hydrogens on it, which means that is bonded to that. Okay, and hopefully already you're starting to see what the structure will look like. Now, just to finish off, there's 3 hydrogen environments, and then we will start to draw our molecule. So we know we've got a C6H5, so let's draw that. Okay, there is your benzene. And then from that benzene we know that there's 1, 2, 3, 4, 5 hydrogens on it, which means there's no hydrogen on this one, which means that must be bonded to our ethyl group, because you know we've got an ethyl group here. So we know we've got an ethyl group, that's missing a bond here. So it makes sense that is bonded to that. And so we finish off making ethyl benzene. Okay, and that is really important to learn this benzene part here and to practice this ethyl part here. Now let's just summarise our learning from that NMR. The first one is memorise that benzene is between 6 and 8. Really easy to recognise, well worth memorising, always looks a bit of a mess because you can call it a multiplet. See that mess there? Typical example, and you can call it a multiplet. Now, if we talk about the relative peak area, that gives you a lot of information. So, you don't need to analyse the peak splitting, but use the relative peak area to deduce how many substitutions there are. So, for example, I've done it in green here because they're the 2 you're most likely to see. So, if it has 5 by it has a mono substitution, means it has 1 group on it. If it has a 4, it has 2 groups on it. Now, when you're actually labelling it, you can either call it C6H5 and then highlight the H, or you can draw it like that and just put a H by it when you're doing the type of proton. Okay, but that is the main learning from there. Get your benzene chemistry, memorise, don't analyse, recognise the substitutions.